Alright, so I've been meaning to make a video for quite a while on how estop loops interact with Linuxcnc. So this is a little scary because people usually don't talk about estop loops because, you know, they're safety related, you don't want to get sued. This is strictly for reference. You need to make your machine safe for whatever comfortableness or local codes you have. This will kind of just give you an idea how everything interacts and how to set up some really unsafe estop loops all the way up to safety relay estop loops. So I'm going to start with really unsafe and kind of give you an idea how things are connected. You really should have a good understanding of HAL, and I think going through this maybe a little bit will help. Maybe some light bulbs will turn on and how the hardware abstraction layer within Linuxcnc works. Within Linuxcnc there are 3 pins related to estop. There's the IO control is the module, so it's emc-enable in, user-enable out, and user-request enable. This is the signal going back into Linuxcnc saying, hey, the estop loop is active. This is the GUI saying, hey, enable the estop loop or disable the estop loop. And then this IO control.0.user request enable, this is actually a one-shot that pulses when you hit you try to pull the estop out on the GUI. So this is used for like latching circuits within the estop loop. So on a basic, if you look at any of the simulation configs within Linuxcnc, you'll see something like net estop loop, and then I'm not going to write the IO control part because my handwriting's bad enough the way it is. So it's going to have one line that says net estop loop emc-enable -in, and then user-enable -out. And this is the line. So what this is saying is these are actually, like, think of them as pins within an electronic circuit, let's say. But they're actually virtual pins within Linuxcnc. So what this is saying is it's making a net, which is like a wire net, let's say. It's saying connect these two pins together using signal. This is like the wire estop loop. So this is the basic setup where there's no external estop at all. And so what happens is you go into the GUI and you click on the estop to pull it out. The user enable goes high, then the emc enable in goes high, and Linuxcnc says, hey, the estop button's out. Or if you were to push the estop in on the GUI, user enable out would go false, and so emc enable in would go false, and Linuxcnc would say, hey, somebody pushed the estop. This is probably the super least safest. You're relying on software and a click of a button on a GUI to enable and disable the estop loop. And people do this all the time, and for small machines where you might pinch a finger, it'd probably be perfectly fine, but I don't like it. The next least safe way to do this is to just, I'm going to draw an estop here. I have really bad drawing. So here's an estop button, mushroom. And then you're going to hook it through whatever interface into Linuxcnc into the enc-enable-in. So now the GUI button doesn't work because we don't have this loop here. Only the estop that's external causes the GUI to know that the estop push is pushed or not. I'm going to do a little circuit so you can kind of see how this works. So you push the estop button, you squash it, it goes, it opens up, EMC enable in goes false, the button on the GUI goes in. Transversely, if you pull the button out, the actual physical button, EMC enable goes true and the button comes out on the GUI. This is one step maybe better than this, but you're still relying on the software, the Linuxcnc software in the computer to enable the estop or disable it. That is not safe. I trust Linuxcnc, but I don't trust Linuxcnc with my life. If something were to happen weird and the computer would pause for a second, or a power supply would glitch or whatever, you hit that estop loop, maybe Linuxcnc is off in la la land and actually doesn't stop the machine. This is the stuff you have to think about when you're thinking about estop loops. So what I'm going to do is wire up this example with actual physical hardware so you can kind of see how it interacts, and play with the HAL a little bit so you kind of see how I do things within HAL, because I do a lot of my goofing around within HAL because it's easy to find pins. You know exactly what the pin names are. You're not typing something in and making a mistake. This way you can fiddle through and autocomplete pin names and copy and paste them into your HAL file after you know that your line is working. But I'll go all through that and go from there. I think the next circuit I will do will be where there's an external estop loop that actually will latch a relay and is totally independent of Linuxcnc, but Linuxcnc will know that the estop loop was pressed or the estop button was pressed or not. But that'll be the next one. But this one will be the basic estop loop, and kind of give you an idea of how it interacts, and we'll go from there. All right, now let's go to the actual computer and hook this stuff up. Let's see if we can make some sense out of this. So this is my laptop. This is what I use for developing. It runs pretty decent real time, enough to I haven't had any problems with it testing hardware. This is a Mesa 7992 here. We've got an estop hooked into some of the GPIO, and this is a Opto22 board. I like Opto22 boards. They are inexpensive. You can get them off of eBay. Really easy way to interface, high voltage back into logic or vice versa. So I'm running one input with the estop and one output right now with solid state relay, which is running the light, so we can kind of get a visual. So Linuxcnc, some of you might already know, there's mainly two config files, minimum. There's the ini and the HAL. The ini pretty much has setup stuff like GUI settings, which I'm using Axis, which display, which GUI you're using, all of the configuration stuff like number of axes, the acceleration and everything for each axis, and stuff like that. This like dir step, dir hold, step length, step space for stepper machines. It would have PID settings for machines that are running PID loops and stuff like that. Input scales, it's pretty much all the settings of the machine are in the INI file mostly. And then you have the HAL file, which is kind of how everything is hooked together. How things are hooked together internally to external, stuff like that. It can actually get data from the INI file. That happens a lot. Like these are setting up the step generators, and here you can see it's actually pulling the dir step and dir hold from the INI file. It's, I mean, once you get into it, I think it's it's not as bad as people make it out to be. So I'm going to show you how I make the sausage usually. So this is actually, you know, I'm using a 7992. I grabbed a 7990 config from the sample configs and added the what I needed for this card. So it's using the HM2 ETH driver, and this is the IP address of the board. This is the board, and this is the number of step gens I wanted just for this application. And that made it so that now I can use this card for this testing. If I was really into this, I'd change the names of the INI file so it made sense, but for this purpose, this is just for explaining things, so don't read too far into it. So anyway, so what do? Well, I'm going to run this INI file, or this config. It's already the default one because I had run it once or twice before. So this is Axis. This is currently my favorite interface GUI. I like it. So currently I haven't done anything other than make it so that it is interfacing with this 7992. So this is pretty much default. So I can take out estop, power it up, I can home the accesses. This is a sample config. I can run this program. But what do we want to do? Well, we want to play around with the estop, right? We want to see how that works. How do I do it? Well, I use a lot of things within Linuxcnc. It's really powerful. HAL meter is really powerful. Like, I want to see what the estop button is doing, making sure that it works correctly. Well, I know because I plugged it in here and I looked at the pin out of that port, and I know it's IO27. So I want to look at the HM2 7992.0.GPIO 27 in. So right now it's true. So if I pull it out, it's false. Hey, look at that. Estop true, false. True, false. True, false. So you also have an invert of that pin, which is the opposite. So depending on the logic that you require, you can use either one. So if I switch to this one, now when it's out, it's true, and when it's in, it's false. If that makes sense. This one is the opposite. In is true, out is false. Pretty easy stuff so far. So this gives me, I'm going to keep this one. Well, let's see, what do I need? I want it to be false when it's in, so I'm going to use the in dot not, the inverse of that. So when it's out, it's true. Does that make sense? You'll see why in a bit. So I'm going to keep this one over here, and then let's look at the default estop loop. If you go in here and look at the meter again, I'm going to look at a signal because I know there's going to be an estop signal, estop loop. It's true right now. Alright, so if I click this, it's false. So does that make sense? I want to make the estop loop, or the estop button, that button. So when it's in, it's false. So when this one's in, it's false. And when it's out, it's true. Kind of makes sense? So how do I go about this? Well, I have the HAL file open here, and I kind of know where things are because I've done this a few times. But you see, here's this line I talked about when I was writing it on a piece of paper. Here's net estop loop iocontrol.0.user-enable out is hooked to iocontrol.0.emc-enable in. So this is the loop. That's why this is, the out is from the GUI and the in is back in again. So all this is doing is making that signal false when it's in and true when it's out. It's completing the loop. So how could we hook this in the simplest form into Linuxcnc? Well, I'll show you how I do things here. This is kind of how the sausage is made. This is where I say you really should learn HAL command. So this command I use a ton. So you run this and it's like an interactive HAL command line. So there's some simple commands like show. I want to show a pin. Well, let's show a signal. Estop, and you can tab complete. So this tells me, just because this is actually what's in the machine running right now, this shows me that the estop signal is hooked to IO control, EMC enable in and user enable out. Exactly the way it is here. Alright, so what do I want to do with that? Well, I want to hook the estop in to the EMC enable in. So the estop loop, or the estop button, is strictly running the GUI. So this is how I do things. Like, I am gonna remark out this line. Alright, and then I do most of my work in the command line here because I know it's correct then. I'm not guessing on names. So I want to unlink, oops, let's be in the right window. Unlink P is the command. You can tab complete these too. And I want to unlink IO control dot user out. I want to unhook that pin because I want the estop to be, the actual estop to be what controls it. So now if we look at the estop loop signal, it's only hooked to one thing because I unhooked the other pin. Clear as mud, I guess. This is, you gotta have faith that this is gonna sink in after a while. Alright, so I could do that here. I could just get rid of this line here. But what I'm going to do is then I'm going to say net estop, and I want to connect it to IO control. Tab complete's your friend. You don't have to type everything. Oh, what am I doing? I want to hook it to the actual input, which is the GPIO 27. Alright, so now the estop's out. You see my estop over here? I push the estop goes in. This has no control over the estop now, the estop loop. I pull it back out. Alright, so granted this isn't safe, but now you have an estop that controls Linuxcnc. Again, you're using software to activate the estop loop. Not a good idea. But in the next video I'll show a safer way to do it. Anyway, so let's put this in. So this is how I do things. Like I will either create a new line, net estop loop, and then I'll copy and paste lines from here. I could have copy and pasted like this, at least for starters. And then I want to hook it to in. Alright, so now that's the new line. It says, you know, using this signal, connect this pin, which is the estop input, to IO control.0.emc-enable-in. So I'm going to save this. And alright, so what do I want to show with this? I want to show, since I don't have like an actual machine hook to this thing, I'm going to show how the estop loop would, pushing the estop would stop the machine, let's say. So what I'm going to do is I'm going to hook that light as if it was coolant. Alright, does that kind of make sense? So where is the coolant pin? That's a good question, actually. I think it's in IO control also. So this is the kind of stuff you can do. I'm going to say show pin IO control. I hit tab. It goes out as far as it can without knowing what else I want it to be. And here we got IO control.0.coolant-flood. There's also coolant-mist. EMC has a kind of cool feature where it doesn't add extra stuff here unless the pins are connected. So let me show you what I mean. I am going to do a net flood, and that's the signal, and I'm going to connect IO control.0.coolant flood to, and I know that this relay is hooked to IO28. GP, HM, GP 28 out. So now I've connected the IO control flood to GPIO 28 out. I'm going to copy this line and put it into my HAL file because I know the line is correct because it didn't error on me. And this is an easy way for you to connect things and play with things without, you know, without screwing up your INI file or your config or your HAL file. Alright, so for that to show up, I'm going to have to exit and get back into Linuxcnc. But this will also show that the changes I made to the estop are also there too. So I'm going to save this. I'm going to get out of Linuxcnc. I'm going to push the estop so you can see that it comes up in the estop mode. Talk about us, telling lies. So here I can't pull the estop out on the GUI, but I can with the actual button. A couple things I forgot to, because I know these things, because I've used Mesa stuff a lot. I have to do a few things to the pin to make it an output and to make it work with Opto22s. So this is kind of a, I don't know, you'll kind of see what I'm doing here. If I look at, if I show param and I show the parameters for the GPIO pin 28, here are the parameters for that pin. Currently they're all false. So right now it's only an input. This is stuff I should have done originally, but we can play with it here and I can put it in the HAL file. So also in here you can set values to pins. So these are all bit pins, so it's either true or false. But I need to set the invert output to true, just because I know I need to do that for the way this is wired. And I need to set it to open drain for it to work with the opto22. And I need to set it as output. So I can do set p hm 28 gp 28 invert output true, if I could spell true. And then you can go up, you can use the up arrow and get that last command. And I want to say also is open drain true, and we'll up one more time, and is output, oops, and you have to say true. See, so it errors if you do something wrong, which is really nice to be able to check this out. So these are the things I want to do for that one pin. So I am going to copy these and put them into the HAL file so that they're there next time. And again, this is how I do it. I don't know how common this is. Alright, so now I set up all those. I'm going to save this. So when I restart Linuxcnc, you can see now there's a flood button here. But the flood won't work. I don't even know if... Oh, look at that. Alright, so I can turn the flood on. This is, you know, running a motor, let's say. But if I hit the estop, it turns the flood light off. Granted, this is all done in software, not safe. Again, I'll say I trust Linuxcnc quite a bit, but I wouldn't trust it with my life. You want hardware estop loops, and we'll get into that. Alright, so I can turn this back. Oops, yeah, I can't do it there. I can turn this back on, and I can turn the flood back on. So this is also kind of a HAL 101, how things are connected. I hope it kind of maybe makes some light bulbs turn on. So I had said this is like the most basic, least safe estop implementation you could possibly have. And then I said, well, how could we make this more functional, let's say, but not safer? And that was using the estop-latch. So how do we do that? That's a good question. So what eMMC has that somebody wrote is a HAL component called estop-latch, and it has 3 inputs, well, more than 3, but this is fault in, this is OK in, and this is reset, and then out. Kind of look familiar to the ladder that was on the previous drawing. So we're going to draw, what do you want to call it? So this is the external estop in. This is user enable out. And this is eMMC enable in. And this is user request enable. Alright, so this works like the ladder did, kinda. The estop, either estop, either the GUI or the external one will cause an estop event or fault, but only the GUI will enable it. So again, I think doing this in Linuxcnc will kind of help you understand what I'm talking about. At least I hope. So let's go on to that and show another example. Alright, so if you look in a HAL file, if you look, most of the time it's towards the top, there's a whole bunch of stuff loading. Like this is the Mesa driver, host mode 2. There isn't much in this one, but these are all real-time components that are loaded. And then these are the functions that are added to the real-time threads. So there's the Mesa read, and then there's motion handler, there's motion controller, and then there's a write. So this is about the most basic HAL file you can have as far as actual real-time modules running. So we need to add, I'm going to stay up here, we need to add the estop-latch. That's pretty easy. You just do a load RT and then estop, you tab complete, and it's the only thing there. So again, I usually take this then and I copy it into the HAL file. So I'm loading RT. Let's load real-time estop-latch. So this is all running in real-time. Alright, so now we want to add the estop-latch function to a real-time thread. So add f estop, and tab complete. It's your friend. You don't have to remember everything. You just kind of have to know what you're looking for. And then you hit tab again, and it'll, because this only has a servo thread, it'll tab complete for you. So I just added an estop-latch function. So now I have the function loaded. So now if you look at this, you can look at all the pins. You can say show pin estop-latch. Here's all the pins. It's kind of cool. So what do we do with that? Now we just have to hook a bunch of stuff up to it. Sounds like a plan, right? So we already have, if we look at this is all we have right now with our estop loop. We have the input 27 hooked to the emc-enable-in. So this is where, if I'm not 100% sure how I should hook this up, I am going to go look on the internet. So if I just type estop-latch Linuxcnc, hey, look at that. So this gives like a man page pretty much of what how it's should be used. So we got all these pins here, and they kind of give an example of how fault in should be connected IO control user enable out is connected to reset. OK out is connected to IO control EMC enable in. So we can kind of start doing some of this stuff. And we can see if we get in trouble. Talk about us. Well, that's annoying. I'm going to just put this over here for now. So so which way did we have this? Let's take a look at this pin. I want to see what we have the estop loop set to. So it's true, it's false when it's in, it's true when it's out. Okay. So I'm probably want to use the opposite logic for that. But we will goof around with that. Because this is how we do things. We goof around with it until it works. So I'm going to, because I think the fault in, the reason why I'm mumbling here is fault in needs to be, the state changes from OK to faulted when this is truth. Fault in is true, which is the opposite of this, because right now when it's in, it's false. So that's where I'm coming from. That's why I'm kind of mumbling here, trying to decipher what I need to do here. So either way, we need to hook up a bunch of pins. So I know I need to set they show out OK is enable in. So net, I have real good naming conventions. Out OK to estop-latch OK out to IO control enable in. Oh, look at that. So it's giving me an error. Does anybody want to know why it's giving me an error? Because this EMC enable in is already connected to the estop loop just right above there. So I'm going to unhook it. Unlink is the IO control EMC. So now I can just run that command again. Bingo. So now we have one pin hooked up. And I'm going to do all this down here. And so if any errors that I get, I'll try to explain why it's happening and what to do about it. So we already have this estop loop hooked up to this pin, but we're not going to use this pin, I don't think. We're going to use the in pin, not the inverted version. So make sure you're in the right window too when you start. Fault, let's try to spell it. My spelling is atrocious. In is IO estop fault in. Alright, does that make sense? To HM GP 27 in. Alright. So now I have the fault in set. And then if you look at the directions for the man page for this, it says, oh, it doesn't say that. Haha, funny. Okay, so what I'm going to do is connect net OK in to IO, and you can look back at the page that I drew on to show why I'm connecting these things together. IO control, user, enable out. Alright, so this is the GUI saying, hey, I want to enable the estop. Or, terminology sucks. I want to pull the estop out or push it in from the GUI. And now the last one is the reset, which is they actually say that IO control.0.user request enable should be connected to the reset. Net reset e stop IO control user request enable. All right. So I didn't make any mistakes. Oh, first I want to copy this over so I don't forget. I'm going to save that. Okay, let's look at Linuxcnc. Okay, the estop is in. Can I pull it out? I cannot pull it out. Does that pull it out? No. All right. So, why isn't it working? And let's see what we're doing. So fault in is fault in. Didn't I connect OK into something? See, I'm let's look here. Latch. OK in. No, I didn't. So this is another way you can do it. You can say net OK in to estop OK in. And this can be 2 lines, or it can be 1 line. So if you look at this, I'm going to put it underneath here so you can kind of see what it's doing. So it's connecting, I'm going to use the mouse because I don't know if you can see this through the video. It's connecting, it's making a signal called OK in, and it's connecting it to IO control.0.user-enable out. But I forgot to connect it to the estop-latch. So I said, okay, net, take this same signal and connect it to estop-latch-0.ok-in. I'm going to save this. I'm going to say that's going to work now. But if you look now here, now the pins that I wanted connected are connected, except for reset. What did I do there? Okay, so I did the same thing here. I connected the reset signal to the IO control.0.user-request enable, but I also need to connect it to the estop-latch. Now, if I'm lazy, I'd probably do this and just do this and then restart Linuxcnc. But since we're kind of showing how we can do interactive stuff, I'm going to also connect it here. So I'm going to say net reset estop to estop reset. So now, if you look at this one more time, everything that I think needs to be hooked up is hooked up. Now let's see if it actually works. Hey! And so now if I push this button, hey! Let me get this out of here. So I like this setup. Some people don't like it, and I don't really understand why. The only comment that people say is they don't like that Linuxcnc can reset the estop loop or pull the estop loop or activate the estop loop. I don't have a problem with that. I just don't want to depend on the software to actually execute the estop, because that's what's happening right now. If I pull this out, see, it actually doesn't pull the estop out. The GUI has to be the one that resets the estop loop. See, if I hit the estop, I can't pull it out when this is pushed, right? So that's good. And when I pull this out, it doesn't pull out and automatically pull out the estop loop until I actually physically tell Linuxcnc, hey, take me out of estop. I hope that kind of makes sense. I think it'll make more sense when we actually get into hardware estop loops, which will be one of the next videos. So this is like video 1, super unsafe estop. Alright, so let's do the same thing. Let's turn this on and turn the flood on. I can hit this estop and the flood will turn off. The flood pump, if it was a pump. And when I pull this back out, this estop is still in. I have to actually physically say, hey, Linuxcnc, reset the estop loop. And now I can power the machine back up and turn the flood back on. Or I can do it here, right? And I can activate it there as long as this one isn't pushed in. So I hope that you can kind of see the method to the madness. This is how I like to play around with HAL, so that when it actually makes it so that I don't make as many mistakes, because I'm not trying to remember, okay, how do I type this IO control .0 whatever. I can do it in this interactive HAL command and tab complete, look at the pins that are available. You want to see, let's make this bigger. And this is a pretty simple setup. If I go show, it shows you everything. And here's all the pins and functions and signals of how everything's connected within this setup of Linuxcnc. All the pins that are available in the Mesa card are here. You know, it's just hell powerful control software. All the accesses information gives you, you know, following error, all kinds of stuff. All the pins for the HAL, or for the Mesa card. Here's all the step gen pins that you connect to things. Then you can actually, these are INI, like max velocity, max acceleration for all the accesses. Here's the IO control. You know, here's motion. Motion is a big part of Linuxcnc. And then here's all of the signals that are created. So here's some of our OK in I created, out OK, reset estop, tool change. I didn't make that one, but you know. And then here's all the parameters, like when I set the output to open collector and output and stuff like that. These are all parameters, and then these are the functions that are running. And yeah, it's pretty amazing to me, and it's just so powerful. Like you can it's scalable. You can use it for your most basic 3-axis desktop router, all the way up to like our Kernian Trekker, which is, you know, it uses 90 some IO, 4 axes of analog servo, rigid tapping, so spindle encoder, gear shifts. Again, I honestly love Linuxcnc. It is, I don't know what I'd do without it. I'd be spending a lot more money. That's all I have to say. So anyway, this I think is the end of the first estop video, and I hope to do a next one sooner than later, which will involve probably initially an external estop loop using like a simple relay, like a latching relay setup, so that Linuxcnc has no control over the estop, and you have to reset it with external hardware, an external button. I know some controls use it that way. And then the final will be the one I really like, which is, well, there'll be a couple actually. The final will be actual safety relay with Linuxcnc enabling it and stuff like that. So I guess let me know if this is of any use, and I guess talk to you guys later.